All right guys, welcome back to the shop. We got another video for you tonight. I'll show you what kind of trouble we're going to get into. Okay, so for tonight we got a project that we're going to be utilizing the burn table and the press brake primarily. So what we've got is something we haven't done on a video before, but we're going to be building a couple horse feeders. I got a guy that lives just up the road. He's got a real nice place, and he called and asked if I could build some horse feeders. It was one of those situations where I told him you could probably buy them for less than you're going to pay me to build them. He didn't care. He wants them built because he feels like he gets better quality, and he wants a specific size and layout. And so he's just one of those customers that knows what he wants, and so we're going to help him out. So here's what we got. I do have a drawing here. I went up and took some measurements. He showed me exactly what he wanted. So this is a side view, 24 inches wide, 32 inches deep on the feeder section, and then the pan in the bottom. We're just going to kind of play with that. I've already got it drafted up. This is a front view. We're going to have angle or rod right here. If you've never seen a horse feeder, this is just how they're typically built. So you put either rod or angle here, and then when you throw the hay in, they pull the hay out of here, and then the leaf falls in a pan so they can eat that. You just get a lot less waste this way. We'll go ahead, we'll show you guys what we got drafted up here. So one of the hard parts about fabricating something like this is knowing how to lay your parts out. There's like 1,000,001 ways that you could lay this out and burn the parts and break it and weld it together. You could do it in separate pieces. You could do it in, one large piece where you break the sides in, and then this is attached to this, which is originally what I was going to do. And I'm sure a lot of this probably doesn't make sense at this point, but it will. When I had this piece attached to this piece, I don't have enough plate because this is almost 4 feet wide, and I'm burning 4x8 sheets of plate. And so when I measured from here to here, it was like 98 or something. And it didn't matter how I positioned the part, it just would not fit. So I thought, okay, we got to figure out a different way to break this. So I've added this section. So we will break here and here, and then we'll break here. And so that piece will fold up, and it will weld open corner here and here. And then this section will break here, here, and here. It'll actually have 2 breaks in it, but 3 sides. And that's the pan that catches the hay. So that's the plan. Hopefully that'll make more sense once we get rolling here. So now that I've got it drafted, I'm ready to load up the plate on the table. We're gonna go out and unstrap the plate, get it brought in here, get it on the table, and start cutting. So we'll go to that point. All right guys, we got our plate loaded on the table. Our file's ready to be cut. Let's do it. Scary. All right guys, so here's the beauty of having a press brake that can break 48 inches wide. I know that if I use a 4x8 sheet, then I'm under 48. We'll be able to slide this in there, make our brakes. It's really a slam dunk. So we're gonna take these parts, we'll take them over to the table. Bridger's gonna start cleaning them up. Make sure he buffs all the plasma slag off of all the edges because all the welds on this are gonna be open corner. He's gonna clean all those up, and then he's gonna help me break it. So we'll go ahead and do that now. So this is also one of those files where I've designed the part now, and this is probably one of those things where this is not the only customer that I'll have that wants a horse feeder. And so I'll go ahead and I'll save this file. That way, if a customer comes to me and says, hey, I need you to build me some horse feeders, I'll say, well, I've already got a file worked up. I can burn them out of 1/8" plate. I've built these before. The customer was happy with the design. Here's some pictures of them. There's a lot of benefits that can come from this if you save the file, take pictures. That way in the future, if you have a repeat where someone else wants the same thing that you've already done, you can show them this is what it looks like. And they could even say, well, I like this, well, I don't like this. You can modify a few things on it. It just makes the process faster and easier, just makes life easier as a business owner. So, all right, we'll go ahead, we'll get these parts taken over and cleaned up, and we'll go from there. The Finger Smasher 5000. That part's not as important because that's not getting welded. Okay, so I got our lines all laid out here. So we're gonna break this piece and this piece up, and this piece is gonna break up at like I think this is 20 something degrees. This edge and this edge should meet and give us an open corner. We'll weld that section up. So our other piece over here, it'll have 2 breaks in it here and here. That'll give us our trough piece, and that'll go to here. So hopefully that makes sense. So now we're gonna pack this over to the brake. We're probably gonna manually brake these, meaning we're not gonna use the back gauge. We're just gonna go ahead and slide this in. We'll brake it on our mark, and we should be good. So I'm gonna have Bridger come back in here and help me get this in the brake and see if we can't get this done. All right, we're getting an education here. So we went over to the brake, and then we realized that this is 6 feet wide, so we can't get this in to finger brake it. When I say finger brake, we can move the tooling around in the press brake so that the knife is only the width of this piece, and then we could bend this piece. But we can't do that because this, the whole width of this, is 6 feet wide, and that's only a 4-foot brake. So we got 2 options. We cut it here, and then we break this and this. The thing that sucks about that option is we still got to move the tooling around, which takes quite a bit of time. And then we break this one, and then we move the tooling back. We break this one, and we break this one. So I've decided we're going to cut this piece right here. We won't have to waste it. It should still be fine. It's only the width of the zip disc that we're losing. So we're going to cut this one right here. We'll be able to put this in the brake because this is less than 48 inches. We'll break this one, we'll break this one, and this one we'll just weld on. That piece the piece for the bottom of the pan. We'll be able to slide that in, break it, slap it on here, tack it up, and fit it. So this is one of the complications that you run into when you have to figure out about how to break things, what size your break is, what size your burn table is, what your capacities are. And this is a fairly small size shop, so I don't have the type of equipment that allows me to break things that are this, 6 feet wide. And so I've got to build things to my abilities, and this is just one of those situations where you got to modify your work so that you can make it work for what you're able to do. And so we're going to cut this off, and then we'll keep rolling. This is life. Okay, got that all cut. We're going to go ahead and get this over in the press brake and break these two sides. Okay, so we got this plate all laid out. Now the other good thing about having the software for the burn table is I can take and measure these angles and then just write down what the angles are, set it in the CNC press brake. That gets me really close, so when I need to fit this up, I don't have to sit and fight it. It's really, really close, which makes life a lot easier. So having nice equipment definitely makes a difference. So we'll get this over the press brake and we'll get our angles put in, and then we'll start breaking it, see how it turns out. Okay, so I'm going to go ahead and make my adjustments here. So the first one we want 36.8 degrees. On this press brake you have to deduct it from 180. So 180 minus 36.8 for 143.2. Alright guys, apologize. I believe my mic died and I had to charge it, so let's show you guys where we're at. So Bridger and I did get the parts tacked into place. You can see how good these joints look. Everything worked out the way we wanted it to. So this is an open corner. For those of you who don't know what an open corner joint is, you can see it's just where the corners butt up against each other, and then you fill this up with weld. And it's one of the strongest joints that you can have when you're building something like this. You don't want to overlap the joints and then weld one side. It's a weak joint and it's more susceptible to crack and break. Doesn't hold up as well. This is much stronger. So if you are building anything like this with plate, typically if you can build it with an open corner, you're better off. If you do have to butt things up together, you're better off gouging it out with a grinder and then filling it in. But this is the method that I prefer. All right, so now that this is tacked up, the other thing Bridger and I got done last night, we went ahead and we cut our parts. This is just 1/8 by 1 by 1 angle. And we're gonna build our frame out of this. So I'm gonna go ahead and tack up this frame. It'll just be a rectangle. And then we'll take and run either our rod or angle or whatever we use for the slats up the center. We'll tack those to the frame. So once I get this frame all tacked up, we'll come back and show you what we got. All right, so one of the first things I want to do here is I'm going to take my pieces for my frame and I'm going to go ahead and bevel all these so that there's somewhere for the weld to go. Anytime I build a frame like this, I like to bevel my parts. I don't like to just lay the weld on top of a flat surface because it's not as strong. This is just how I like to do it. So we'll go ahead and bevel these, get them all prepped up, and then we'll start tacking it together. All right, so then I'll take my frame here, and this isn't something that's going to have to be perfect, but we do want to get it close and we want it to be consistent. So we're right on 24 on an OD. So we'll go ahead, check this for square, tack the first corner. Now I'm going to tack my second corner. Okay, so then when I get a frame like this tacked up, I like to start with my gouged corners here. So when I bevel these, I'll show you guys what these look like. So there's what my joints look like. So there's a nice V groove in there, somewhere for the weld to go. And on the inside, might be hard for you to see, but there's a V groove on the inside as well. Gives you somewhere for the weld to go. It helps the weld lay flatter, and then it's not piled up on a flat surface where it doesn't get penetration. This also helps it get penetration. The outside corners, you can see it looks like an open corner joint there as well. So that'll give you a stronger frame. If you do have to build a frame, try it this way, and I don't think you'll be disappointed. On an open corner joint, it's okay to run short arc downhill. It's faster, it's cleaner, and especially on an open corner. So if you're running an open corner joint, and I'll try to show some video of this, it's easier to run solid wire short arc downhill. So that's the way I ran this. So I'm going to clean this up with the grinder real quick, and then it's going to be ready to tack our rods or angle or whatever we decide to use there. So I'm going to clean this all up. Once I get this cleaned up, we'll come back to you. I need to see what kind of material I want to go with. I may go with rod, I may go with angle, but I want to compare both and see what I like best. All right, so I've made up my mind on 1/2 inch rod. So I cut these to 35 inches. You can see they fit down inside this frame just right. I've got some 4-inch spacers here. So I'll go ahead and tack this, move my spacers, tack the next one, move my spacers, and so on and so forth. Okay, so now our frame is ready to get tacked in here. So I'm going to go ahead, grab some clamps. We'll get this clamped where we want it. Okay, I think I like that. Now I've clamped this on here to where there's an 1/8 inch open corner joint down these outside edges. That way I can run my welds down this, and I haven't decided if I am going to stitch weld these joints or weld them solid. There's really no need to have this welded solid, plus then you run the risk of it warping. So I'll probably just stitch weld it. So we'll go ahead, we'll lay our stitch pattern out, and this will be ready to be welded out. Now I don't think I'm going to weld this solid inside either. There is one joint here on the bottom that is open, and I'll show you guys. There's not a break in it. So it's plate butted up against each other, and I like that because I'm going to stitch weld that joint on the outside. That way, if there gets to be moisture in here, which there eventually will be, every time it storms, there's going to be some moisture that gets in here. If I just stitch weld it, that leaves gaps every 2 inches where moisture can drain out of it. So it's not filling up with water. Then every time the horse wants to eat, his food's all soggy. Nobody likes soggy food. So we're going to go ahead and we're going to stitch weld that so that we can have a natural drain. All right, let's go ahead and get this tacked up. So I like to put tacks on the starts of everywhere where I'm going to put a stitch weld. So before I go ahead and weld this out, there was one thing I wanted to go over, and that's how I like to weld out these open corners. Something like this with short arc, I'll usually whip it downhill. When I say whip it, I run it kind of back and forth. So just like a whip downhill. So I'm actually going to add one tack to this in the middle just to keep it from spreading on me. Just a small tack. Okay, so I'm going to run this one, whip it downhill, and it shouldn't get away from me. Sometimes the puddle gets so big that it can get away from you. If you're managing your speed and your wire feed and your settings on your machine, it shouldn't ever get away from you to the point where you have to stop. So let's give this a try and see how it goes. Okay, so that's a really quick way and a clean way to run these type of joints. Now let me show you what it looks like. Okay, so you can see it's pretty consistent, and I don't know if you can see it, but if you look at it, it fills that joint really nice to where it just kind of rolls over. You don't want to fill it too full to where it's protruding out of the joint. You just want it to hit these corners right here, which I think we've done it. So I just wanted to show you guys that. That's how I like my joints to look on an open corner. If it's something flat like this one, I'll run this one right now too, and I'll show you what it looks like. So you got to keep your speed a little bit more consistent on this. On this one, on this type of joint, you've got gravity helping you. And so you basically just run that little whip, and the bead will kind of fill in where it needs to. You just kind of have to control your speed. If you're running one that's horizontal, it's a little bit tougher. You got to make sure that you keep your speed consistent. It ends up looking the same way. Hopefully you guys can see that. You know, stuff like this start right here where it's kind of bled over the edge. I'll just take a flat disc, clean that up a little bit at the end. Stuff like this little berry right here. I like to clean that stuff up, make it nice and consistent. This is what I like it to look like. So I just want to show you guys that. I'm going to go ahead and weld this out. We're going to turn up the speed on the camera, and I'll go ahead and whip this out. And then once I get this done, the only thing left to do for the feeder once we get it welded out is we got to fabricate the hooks on the back, and I'll show you what I got in mind for those once we get this welded out. So let's weld this out and we'll go to that point. All right guys, let's give you an update on where we're at. We've got our second feeder built. The only thing left to do is to fabricate the hangers that go on the back of the feeders. Now, I do have an idea, and here's what I'm thinking. Let me bring you in close here and I'll show you what I'm thinking. Okay, so this is kind of a die that I made for my press brake attachment on my iron worker, and I was using a piece of round stock to bend some flat bar. So I built this. This is the die, and then I was using a round piece of, like a piece of shaft, piece of round rod attached to the press brake arm, and it would press this down. So the style of hook that I'm looking for, so it'll be about like this. Now, to be able to do that, what I'm thinking is I've got two pieces of 3/4 plate here. I'm going to weld these on here, and they'll be the width of the panel. So the panels are, I believe what this is, which is 1 5/8 on an OD. I think they're actually tube, but it's the same OD as this. So 1 5/8, and then I've got a 10-inch piece of 3/16 flat bar, 2 inches wide. So I'm going to lay this here, and then I'll set my piece of pipe on here, and I'll use the press to drive the pipe down to try to bend this. I think it's going to work. We'll definitely have to weld these on 3/8 wider than our pipe. so that there's enough room for that to move once it gets pressed down in there. That's my goal. I want to try and get these tacked on here. We'll go over the press brake. We'll set this on here. We're probably going to have to rig something up for this to get this pressed down in there, but we're going to try it and see what happens. Sometimes you have to build a tool like this to make what you want to, so we're going to try it. We'll go ahead and get these welded on here, and then we'll go over the press brake and we'll show you guys what we're thinking. All right, so I've tacked this to the pipe. We're obviously going to have to use something to drive it down once it gets past this surface, but we want to see if it can even get it to that point. Well, that really didn't hold up, did it? Should have used dual shield. Son of a gun, I think it's going to work. We just got to get it down the rest of the way. Yeah, go fire up the dual shield machine. So we've triple passed both plates with dual shield. We're going to see how far this will press down in there now, hoping it doesn't break. Obviously, we're only going to be able to go down a little bit further, and then we got to use something to push it the rest of the way. Let's see what happens. About as far as we can go. Okay, now this is where it gets sketchy, so we're gonna hide. Okay. Oh snap, it worked. I think it worked.
How are we gonna get it out?
Well, I left enough room that we should be able to just beat it out of there, so stand by. All right guys, here's what we got. That's exactly what we wanted. I wanted plenty of overlap here so that it will hang on the fence and you can actually lift it up a little ways before it will fall off. Sometimes horses get to screwing around, they can nudge it with their nose or whatever. I wanted there to be a little bit of security there, so that's why I wanted to do it this way. So I'm pretty happy with how that turned out. It fits on the pipe just right. So we're gonna go ahead and do the rest of them. And then once we get them all done, we'll go over and get them welded onto the feeder. Okay, so you can see I just go until it touches the corner of this foot. And then I've got to get the little cheater out here. Then you got to hide. Goodness. Getting it out, you just got to smack it with a hammer. I mean, it does tweak it a little bit, but I just bend that back with the hammer with the vise. It's not perfect, but if it turns out like that, it's good enough. All right, we'll get these all pressed, and then we'll meet you over at the feeder when we get ready to weld them. So, 36 inches off the ground, panels are 64 inches tall, okay. So there's our hooks. Welded them solid. So we'll go ahead and stand this one up, give you guys one last look. All right, so here's our horse feeder. It's got a nice big hopper, so it'll hold lots of feed. It's got a nice sloped trough or catch pan. We did leave a couple slots in the bottom so that it will drain. We did add our hooks on the back, so it'll hang on a panel. I did send the customer a picture because they wanted to see it. They're pretty excited. So we're gonna get the hooks welded on that other one, and then I'm gonna haul them up there tonight. I guess they need them pretty bad, so we'll get them hauled up there and then they can start using them. All right, so that's gonna wrap up our horse feeder video. Appreciate you guys watching. Hope you guys enjoyed it. Have a good night. We'll see you on the next one. All right, so tonight we got a project that's gonna, the only thing left to do is to fabricate the hangers that go on the back of the, goodness. All right, so we've laid a line out right here. Goodness.